Hey y'all, today I'm back and I know I've been away for a very long time, but there's been a lot of people reach out saying they like my videos, so I think I'm gonna get back into it. So what better way than to do two-sum, which I realize I've never done the solution for. So yes, this is Leetcode problem number 1, two-sum. So basically it's asking something very simple. They give you a list of numbers and they give you a target. You just have to find two numbers that add up to the target. But you don't return the two numbers, you return the two indexes of the numbers. So like you have a list, it starts at 0, right? 0 is the first number, that's the index. Okay, anyway, so I'm going to go over two solutions. One is the kind of intuitive, like lesser efficient solution. And then one is the kind of standard solution that you're supposed to know for this problem. Okay, so the first thing first, let's just go intuitively and we'll do the rougher version, which is we're just gonna go through each pair of numbers and find the one that adds to the target. So first we're gonna go like for int I equals 0, and we're just gonna simply go through the nums, and we're just going to do a standard loop like this. And we'll start this one at I plus 1 so that we don't duplicate any numbers. And we don't reuse the same number, because if we start at I plus 1, it'll never be I. So we'll never like add the same number with itself. So it kind of takes care of both cases. So this here, we're just, finding all pairs of numbers. So then now that we have, this will actually get us all unique pairs of numbers. We can just find out if it adds to target, right? And then if it does, we can go if nums I plus nums j is equal to target, we can simply, what is it asking for? Look, it's asking for the list of indexes. So we don't return nums I and nums j, we actually return I and j because those are the indexes, right? And it's asking it for it as int. So you can do like return new int, something like this, right? I and j. I think this works, I forget. And then because you need to return something, we'll just return like a dummy here in case we never found anything. So let's run this. Let's see if this works. Looks like this works. In fact, let's even submit it. Looks like it is 38% runtime, which is not extremely desirable. So let's go over the solution and why it's a bad one. So intuitively, it makes sense. We're just simply getting all pairs and then finding the pair that actually adds up to the target. So it does exactly what the objective is. But the reason why it's inefficient is because of the time complexity. We actually go through all the numbers and we go through all the numbers again. And it's based on n, where n is it grows with n, which is the number of nums in num or whatever. And it does it twice. So it's actually the time of this solution is big O of n squared. Now, what if I told you we can get it to n, which is extremely desirable, because if you have a large input like a million squared is pretty large. I don't know, is that like a trillion or something? And sorry, I mean n. We would much rather have, if we're given a million, just loop a million times, right? That's actually something that a computer can do pretty fast. The other one could be a bit slow. So anyways, so how do we make this more efficient? So this is where the knowledge of data structures comes into play, and we can actually pre-cache the numbers that we've seen before. And I'll explain how. So first we want to make like a cache, basically. And I will go map integer cache equals new hash set. Sorry, I mean hash map. It's been a while. So this will be our cache, where we'll cache the numbers that we've seen before. And then we'll simply go through the numbers again, just as we did before, but in a slightly different way. And then we just have to think of something. So what are we looking for here? So we're looking for some x, and x is the number we don't know, plus the current num, so nums at I, is equal to target. We have the current number, we have target, so it's basic math, right? We don't know the x, so x is actually equal to the target minus nums I. And see, it's like basic math, you just minus nums from this side and then put it over to the other side, right? So this is actually what we're looking for. We're looking for that x. So we can just see if we've already seen it before, and we'll go if cache contains key target minus nums I. See, I'm just doing the equation that I did before. So have we seen this before? Then we're going to return it. And we're actually going to return not only the current index that we're on, but the one that we pre-cached. So we'll actually fetch it. Target minus nums I. So basically something like this. Now, how we know that it's in the cache is because if we haven't seen it, we cache it for later for every single number. So we just simply go cache.put, and then think about what we're fetching. We're actually fetching the index. So for this number, so nums at I, we cache I for every number. And let's run this again like this. And let's submit this, and we should see the runtime is now like closer to 100%. It's way bigger improvement. Now, why is this better? Well, let's actually go through the time. The time here is I only see one loop. And here, these are like constant time operations. A lookup in hash map is constant time. You can consider it constant time. And so basically, if we're just doing a constant operation, n times, it just comes out to be O of n. Space is actually O of n also, though. The other solution is actually constant space because we weren't storing anything. This time we're actually caching everything. So keep that in mind, as you should know the key difference. This one's a lot more time efficient, but it's less space efficient. So if you're optimizing for space, assume you're working in some theoretical system where you can't use any space, then the other solution would actually be better. But I just wanted to cover these kind of in a simple way, and I hope that this was helpful in some way. Yeah, and I'm going to try to make more videos, so nice to be back. Thank you for watching.